My name is Marcus Grimm. I'm joined today by Jon Santavy. A lot of you know him. He is one of the partners and chief revenue officer here at SimWell. And today we are going to be walking through 8 questions that come up constantly in supply chain planning and why even some of those sophisticated planning tools might not be able to answer them. Jon, I can't tell you how thankful I am that you are joining us right here. How are we doing today?
Fantastic.
We are thrilled to have you here. Listen, before we get into this one, I definitely do want to set the frame for the people in the room. This is not going to be a pitch to rip out your planning tools. As we were working on this presentation, Jon, I thought so many of those times in my life when I was growing up and I was doing projects around the house and I was trying to get something done. And then my father would walk up and he'd reach into the tool bag and he'd get out the exact perfect tool. And, it's all about using the right tool for the right job. And that's really what we're going to be talking about today, is that gap between how we plan and how the systems actually do show up in reality. So quick look at the agenda today. We're going to define what we mean when we say planning tools so that we're all on the same page. We're going to talk about what they are very good at and where they hit a wall. And then we'll walk through 8 supply chain questions. These are the ones, Jon, that you say you hear all the time. And at the end, we'll talk about, what it actually looks like if you use the right tool to answer those questions. So without further ado, let's keep moving here, Jon. This word that we use a lot, planning systems, planning tools. When we talk about these, we're talking about the layers of tools that are used across an organization, right?
Yeah, absolutely. When you talk about planning in this session, we're really talking about the systems that structure decisions before an operation runs. And that's really the context for everything we're going to explore here today.
And to be clear, you're not talking about replacing any of these, right?
No, not at all. When a plan is built from these structured inputs, the forecast, the capacity, the lead times, the policies, they're all structured inputs that go into it. And those inputs define a target state, but the execution of it is not a target state. It's a sequence of events that unfolds over time, and performance emerges from that flow of events. That's why we see this gap with planning tools and how operations are really working. So today we're going to walk through those 8 questions that live in that gap.
And when you talk about this, we've got a series of short videos here, which are going to be kind of fun. And I think as we play these videos, people might be able to see themselves in certain situations here. So let's see what our first speaker has to share with us about his plans.
Monday morning, I'm walking into a room full of people to defend a plan I already know isn't going to hold. And the worst part, I can't tell them where it's going to break. I just know it will. I've seen this movie before.
Yeah, I think we all have. Ouch. And what we see here are situations where organizations have plans. The plan has been approved, but that plan we really know it's not going to fly, right, Jon?
That happens. It happens on Tuesdays. It happens with forecasting. It happens with schedules and new policies and processes. And it happens with capital projects too.
It happens across the board. And so that's sort of the setting for today's program. So with that backdrop, these are the 8 questions that we're going to walk through. These aren't hypothetical at all. These come directly from conversations that Jon and his team have with supply chain leaders. And obviously, guess what? These probably aren't the only 8 questions you're dealing with. But Jon, if we make a list of the top ones you hear, these are the ones you hear quite a bit, right?
All the time. Different companies, different industries, but they're really the same core questions. And we recently came out with an ebook on this topic because we're having these conversations with folks and they all feel a very similar problem, but they don't know how to explain it and they don't know how to solve it. So they ought not to feel alone about it. And so we'll be sending that to everybody that's joined today. It's called 8 Questions Your Planning Tools Can't Answer. So look out for that after this session.
This is the live version. Is that right, Jon?
That's right.
All right. Okay. So let's get into it. Planning question number 1. How much capacity do we really have? Here's another short video.
Every week it's the same question. How much capacity do we really have? And honestly, I don't trust the number.
Because it depends on the mix, who showed up, whether maintenance actually happened Tuesday. It's different every day. So
we've got tools, we've got meetings about the tools. Still can't give a confident answer. The operation won't hold still.
Yeah. How much capacity do we really have? And that's a question that comes up a lot. Everyone's trying to get more out of the assets they already have. But before you invest in more capacity, you need to know how much you're actually getting from what you have. And this is interesting because that question, I think a lot of people in the C-suite will go, well, of course, our planning tools should be able to answer that. But that's a hard question to answer, John. Why is that?
Yeah, it's because the number most teams are working from is somewhat theoretical. It's what the supply chain should be able to move under ideal conditions, or the distribution center or the plant or the line, right? But ideal conditions don't exist. Variability does, resource constraints do, unplanned disruptions do, and those things compound across the network in ways that planning tools don't capture. And it's because they treat capacity as an input, not as an outcome. So what that means is that most organizations are either leaving capacity on the table and they don't know it, or they're carrying more exposure than they realize, and they won't know that until something breaks and it actually hurts them. So simulation lets you measure what the network can actually and consistently deliver under these real operating conditions. And once you have that, you can plan against reality, which changes every capacity decision you make from that point forward.
Yeah, it's really well said. And so you explained to us really well there why our planning tools can't do it. So what happens differently when we have simulation in place?
We can run the network forward under these real operating conditions, the real variability, the resource constraints, the disruptions, and we measure what it can consistently deliver across all those conditions. So what comes out of that is a number, like a point solution or a point number that we need to defend. It's clarity on where the network has room and where it doesn't, and why. And that changes every planning conversation downstream, like service commitments, investment decisions, growth targets. All of it gets grounded in how the network actually behaves, not how it was designed to behave. So now you have a way to really understand capacity.
That's really interesting. So now we can understand capacity, but of course, all these questions just have a way of bringing up other questions. Because of course, once we talk about upping capacity, now suddenly bottlenecks start showing up, and well, we all know what that's like.
The bottleneck, we fixed it, and then 2 weeks later, everything's backed up again, and somewhere completely different.
Because the constraint moves. You change the mix, you lose a shift, a rush order hits them, and suddenly it's not where it was yesterday.
So we keep solving last week's problem, and by the time we catch up, it's moved again. We're always one step behind.
Yeah, boy, that certainly sounds familiar. And I think what's interesting about this particular one, John, and you talk about this, is a lot of people always assume the bottleneck is the bottleneck. It's that one machine, it's that one station. What's wrong with that type of thinking?
It's not wrong. It's just incomplete. Bottlenecks move. They shift as work flows through an operation. So most tools and even spreadsheets are really showing you a snapshot. They're not showing you how the system moves, how it flows.
And so when you use simulation, how does that look different then?
We model the network across demand scenarios, mix, operating conditions, and we can watch how flow changes with that. So where does it slow down? Where does it back up? You can see where the problem is heading early enough to reroute, reposition, or replan before it becomes a service failure or a more expensive problem to solve.
And so it becomes one of those things where you're not reacting to the problem as much as you're positioning your resources ahead of it.
Yeah, exactly.
So that's interesting. So as we think about flow behaves as these conditions shift. And so I know when we talk about conditions changing, a lot of it, and boy, this one I know kept you and the team really busy over the past few years coming out of the COVID area is what happens when demand spikes, right? So let's hear a short video here.
What happens when demand spikes 20%? Well, I can tell you what the plan is, but I can't tell you what actually happens to the network.
The tools optimize for the forecast, but they don't model what happens when the forecast is wrong. And it is always wrong.
So every time we get a surge, we're scrambling, making calls, moving freight, and figuring it out in real time.
So this one's an interesting one to me because I would assume if I have a planning tool, you usually don't buy planning tools when you're expecting demand to continue to go down, right? We're trying to figure out how we manage that demand. And so to me, this is the type of question that if I'm working in an organization and the C-suite comes to me and they say, hey, listen, we've got some ideas. We think we can drive demand up 20%. I would feel like I could get that out of my planning tool. Why doesn't that work?
A tool that a lot of folks use and we use ourselves as a network optimization, right? And a network optimization study tells you where things should be. But it's built for the best answer for a defined scenario. Like, where do we expect growth over the next few years? A very strategic planning tool. But the world we're operating in right now, with tariffs and suppliers going down, demand coming in different than the plan, that's not a defined scenario. So it's a constantly moving target. And every time something changes, the optimal design you built your plan around with that network optimization tool or whatever planning tool you have may no longer reflect reality.
It's one of those softball questions, John. It's not in our outline, but you made me think of it, is how you've talked before about simulation's been around for a very long time, right? But you talk about the fact that in this past decade, or in particular this past 6 years, the business has just gotten so much more complex that's kind of what I hear in this particular question is demand isn't just demand. It's demand compounded with other changes in the system. And that's why you kind of feel like this is where a lot of the demand for simulation is coming from, right? Just that increased complexity.
Yeah, that's absolutely right. It is near impossible for a person or a spreadsheet or most tool, even AI, to predict how something is going to perform. We're going to talk about that a little bit later on, where simulation uniquely fits within this technology stack to help answer these questions.
Great. And so when we think about this again, this demand spiking 20%, just paint a picture of how simulation can help with that.
That's exactly what a simulation-based digital twin helps with. And I bring that up because we do a lot of network optimization work, but we start with network optimization, and then we take that same model and we integrate it into real-time systems or near real-time systems so that we have an always-on scenario planning engine. So when a tariff hits or a supplier goes down or when demand comes in different than it was planned, you're not rebuilding your analysis from scratch. You already have a live model of how your network runs, and you can put the new reality in and see the impact right away.
That's a great way to use simulation in these scenarios where demand is spiking. So I think we've gone through 3 questions now. Let's head on to number 4, because I think this is one that really comes up when people are trying to make decisions. What happens when somebody wants to spend money to fix something? So will this investment actually move the needle? Let's take a quick look at a video here.
We're looking at a big capital investment. The business case looks great on paper, but will it actually move the needle?
If the model shows the upgrade in isolation, it won't show what happens when it has to share labor and downstream resources with everything else.
So we spend money and our performance doesn't change because the model assumed everything else stayed the same. It never does.
One of the most interesting types of projects that I think you do at SimWell are these projects around capital investments, right? And people have been evaluating capital projects like these for decades. Oh, look, they still don't always work out. And that's why a lot of folks call on you. Why is that? What is tough about capital planning that you would think a planning tool could handle?
Yeah. And this really is where a lot of our conversations start. And in our setting, it's usually something to do with system behavior, right? Because nothing operates in isolation. So if we size dock doors or equipment off of our average volume, or it may become a bottleneck at a critical part of the day, or if we look at automation investments like an ASRS not getting near their target, I guess to answer your question, what did they miss when they made those big investments that didn't work out? It's not necessarily that they missed something. It's more that we tend to optimize locally versus global optimization. And so they may have found the best answer for the area that they're working on or for the node in the network, but not for the supply chain overall.
Yeah, it's a great point. So when you say, okay, so let's figure out how we would model this, how do you look at these capital investments with simulation then?
We test the investment in simulation, which means you can really right size the ASRS before you commit and everything around it. You can right size your fleet. You can right size your network. And that's a huge difference.
Yeah. So talk to me about, at the end of the day, these capital decisions, they happen in big rooms, important people making big decisions. What exactly are you walking into that approval meeting with when you've used simulation?
I could talk about this a lot, but there are a lot of things about this, but it's really a business case that's supported by systems level evidence. Spreadsheets just can't capture the complexity of these systems. And, if we know that vendor commitments are best case scenarios. So with simulation, you've actually run the investment against the operating reality to get a more realistic understanding of performance. So you're walking into that meeting with this system level evidence, and you have it's not just a bunch of numbers. You have an animation of the operation. So everyone can see how it's working together, or see what's actually happening in the real world between scenario A or scenario B, so they can get behind that investment.
Yeah, which seems to make a lot more sense. And of course, so much of this type of work that we do is all about de-risking decisions, right? And so I think what's obviously interesting when we're looking at a capital investment is you have a lot of risks that certainly you can plan for or anticipate, but as we move on to this next question here, let's talk about the risks that you can't control. So here's an example of one.
I've got maybe 3 suppliers I really worry about. If one of them goes down for 2 weeks, I honestly don't know what happens downstream.
The planning tools assume supply shows up, but there's no mechanism to model what happens when it doesn't and how far that impact travels.
We're in crisis mode every time, making calls at 6 a.m., figuring it out on the fly. We never see it coming the same way twice.
One of my favorite quotes has always been, "Man plans, God laughs." And this entire program, we're talking about these planning tools, right? And so that's kind of what we're getting at right here is we've got our plan in place, but along the way, every company does have that risk register somewhere. So how do these planning tools fall down when you talk about risk like this?
We were at the Gartner Supply Chain Planning Summit this year, and we talked to the folks that lead their risk part of their business or their offering. And one of the things we learned is that organizations do keep track of all these risks, but they have no way to play them out, right? And that's really where we come in, because the problem isn't the risk or the event, it's how it disrupts the business, which isn't always straightforward. So teams need a way to understand how a disruption travels through the network so they can plan for it.
These things happen and we know they're disruptive, but knowing something's disruptive, that's part of it. But how exactly are we going to respond to that? So in our next slide here, you kind of walk through how you do that with simulation.
One of the interesting things about simulation is that it's not like most other predictive tools, whether those are spreadsheets or optimization or AI. We're not making predictions based on historical data, or I should say just on historical data. We're building a digital model that mimics how a supply chain works or how a distribution center works or a manufacturing plant. And that's important when we talk about risk. With the simulation, we have a model and then we run data through it. So we're not predicting the impact of losing a key supplier based on historical data alone. We're testing it in this risk-free environment because we may not have, there are so many of these disruptions that happen today. Snows, big weather events, natural disasters, contested shipping lanes, closing airspace. We don't have historical data on all of these things. So what we do is we run it thousands of times. We predict how the system is going to perform in that range of outcomes so that we can plan for it and mitigate the risk.
Lots of times customers will have plans in place that provide these protections. Do those plans tend to hold up when you look at them through the lens of simulation?
That's the real question. You can test mitigation strategies, whether that's how a safety stock policy plays out or alternative transportation modes and routes. But we can test those things and find out if they hold up.
Excellent. So now you've stress tested the network, you've tested your investments, and you've mapped your exposure. This next question, we've asked a lot of, I think for a lot of this presentation, we've been looking at planning tools. And again, just looking at how they provide tremendous value, but it's not always the right tool for the questions you're trying to answer. Let's take a step away from those planning tools altogether, because even when you have a team of people trying to make decisions, it's not always easy to get people on the same page. So here's another video.
Getting the plan done isn't the hard part. Getting everyone to agree on what it means, that's where it falls apart. Every time. We look at the same spreadsheet and read a different story. Finance sees one thing, operations sees another, and sales says just do more.
So we debate the numbers instead of making the decision. And by the time we align, the window's already closing.
Sales says just do more. Regardless of the industry, John, I think that I think that clip stands up. And this isn't a technical question at all, right? It is a people question. And again, I think what's really interesting about these 8 questions, John, is you went through an exercise where you looked at the ones you're getting, and this one comes up a lot. So a people question coming to a technology company like SimWell, what's going on here?
There's always a lot of dynamics at play, but from what we've seen in these big decisions that need to be made, the root of it tends to be that these teams or people are optimizing at a local level, and they don't have a shared reality of how it impacts the business as a whole. So in other words, everyone is well intentioned, but they may not see how their decisions create a huge problem later in the process. So they're trying to optimize locally because that's their primary point of view.
I think that's really, really well said. And, you talk about why these planning tools struggle. The outputs don't show how the plan actually plays out. Stakeholders fill in the gaps with their own assumptions. We're all guilty of it, John. So how do we fix that with simulation?
This is one of the fun things. It's not just there's a ton of data, and that's really the reason why we do simulation. But I talked about the animation a little bit earlier, and the animation of the operation and it moving through. It's not just an animation; it's a simulation. So it's showing how different scenarios will actually play out, and it makes the system behavior visible. So it's not just a summary of numbers or a spreadsheet, but it's what actually happens when you run the plan forward. So when you do that, everyone sees the same outcome play out. It takes a lot of the emotion away from those types of conversations, and it really shifts it. So instead of arguing about what will happen or whose numbers are right, you're talking about scenarios and deciding what you should do about it.
Yeah, so the debate changes then.
Yeah, completely. It goes from, I don't think those numbers are right, to, okay, given what we just saw, here's our best move. So you can align faster, you can commit earlier, you stop relitigating, all the same options that you have in the past.
Outstanding. Really well said. Folks, I do want to remind you, I think we're heading up. We only have 2 more questions left. Feel free to put in any questions that you have in the Q&A. John and I will be taking those at the end. This is a fun one. So, John, at this point, it's good. We've got everyone aligned now, right? So we've gone through a lot of things. We've made some capital decisions. We fixed our bottlenecks. Now we've got people saying kumbaya. Everyone's agreeing with the plan. That's a wonderful thing, right? Because we want that in place for when something goes wrong. Because as Murphy reminded us, eventually something's going to go wrong.
We've seen it many times. The math works and the plan looks perfect on paper. Then something breaks.
The tools say the plan works, but they don't show where it cracks when 3 things go wrong at once.
The plan says ready, but my gut says we're fragile. And I've got no way to test that before we are live.
When you and I were reviewing these questions, John, I said, you have to help me understand this. To me, this is just a slightly different version of our capacity question, but you kind of pushed back and said, actually, it's different. And I want you to break that down for us.
Capacity asks, how much can we produce? This one really asks how much your plan can survive. So your planning tools will do feasibility checks against resource availability and sequences that you build into it. Right. And they'll balance capacity on paper. They'll give you a green light based on these static assumptions that the tool uses. But there's a difference between a plan that's feasible and a plan that's resilient. Traditional planning tools validate feasibility, but they don't test that survivability.
It seems like in a world where so much is changing so fast, that's really critical. So when you're asked to do that, when you're asked to answer this question, what's going to break first when we push the plan? How does simulation help out with that?
We call this exception handling, and we really run the plan forward in time with the variability and all the interactions baked in, and we find the failure point before it shows up in the supply chain.
This is really interesting. I think you've helped me understand the difference between feasible and resilient. I'm probably going to try to use that with my kids because these really are 2 different things, right?
Yeah, exactly. Simulation is going to predict where you'll have issues in a risk-free environment so you don't find out in the real world when it costs time and money.
Outstanding. Okay, so at this point, we know what we can handle in the plan. We know how to handle the bottlenecks. We've got the team on the same page when things break. But at the end of the line, I do like this last question we have because I kind of feel like it in many ways this is sort of the question that all questions boil down to.
I'm about to ask leadership for a big decision. The first thing they'll say is, prove this will work.
I believe in the plan, but all I can show them is a spreadsheet and a forecast, not proof.
Telling leadership you think it will work and showing them it works, those are two completely different conversations.
John, those are two very completely different conversations. And it does feel like that this is sort of the question behind all the other questions, isn't it?
Yeah, it is. Every one of these comes back to the same thing. Someone is about to make a decision and they're unsure. What most tools give you is a point estimate about how something is going to work. You get a number, but you don't get a demonstration. You don't get to see how it's actually going to play out. So there is some faith in there. And that's really the gap. The confidence you have is based on your assumptions and your experience, which is important, but it's not on observed behavior of the system. So you have to trust the math, but you haven't seen it play out.
Yeah. So when you're, I think, how do we know this will work before we commit? I think at our most recent trade show, you had a brand new banner, test before you commit. How does simulation allow us to do this?
We run the decisions that we're making or the plans that we're making through the system. Again, whether that's the supply chain or the warehouse or routing or whatever, but we run it through the system before you commit. We're not just looking at one forecast. We're running hundreds of scenarios. So you can see what happens across the range of conditions that you might actually face.
I think that makes sense. So when you do this, then again, what changes when you walk into that planning room?
Everything. Instead of a spreadsheet and asking people to trust it, you walk in with evidence. And when someone asks, how do you know this will work? And say, we ran it and here's what we saw. And that's a totally different meeting.
Yeah, it definitely is. Well, those, in fact, are our 8 questions. And I think as we look back at these, John, there's definitely some through lines here, right?
Yeah. They're all asking the same thing. What actually happens when the plan meets the operation? So your planning tools are built to make the plan, and simulation is built to test it, not to replace your tools, but to close the gap between what the plan says and what actually happens.
And I think that that's something that maybe gets lost sometimes because we have all these planning tools. And so sometimes we're like, oh, are you saying our planning tools are wrong? They're bad. And it really is just an apples, oranges thing and what your planning tools do compared to what simulation really looks like. Now, we've looked at 8 of these big questions. I've seen the questions SimWell answers, and there's way more different ones, but these are kind of the big 8 ones. But I know lots of times an organization is thinking, well, we could test this, we could test that. If people are at the point that they're like, I get it now, I understand why I've been trying to answer my capacity question with this planning tool, and it's never going to be able to do it. What does step 1 typically look like for engaging with SimWell?
Really just having a conversation. These are complex systems, and it's hard to understand, will this tool fit and how it'll fit, right? So just having a conversation, and we can talk about what the decisions are that you're trying to make. How will this be different than what you're already doing, and how it'll move your business or change your business and have an impact on it. So it really starts with just having that conversation.
Yeah. And I like the idea, you often talk about, hey, listen, this doesn't look like come in and you're going to have a whole project here. But the idea of, okay, what is this one question? What is the one question that's actually keeping you up at night? So speaking of which here, I'm going to actually go right here to this slide right here. Which question does keep you up at night? And I'm going to open it up here to questions as well. John, one of the questions that I had for you is, it was interesting when you looked at these 8 questions. SimWell works in 10 different verticals. Obviously, supply chain is the largest. We've got people here from the mining industry, oil and gas industry. It seems like even at the highest level, these are the same types of questions that come up, regardless of the industry. These planning tools aren't built to do the types of work that simulation does, right? So that's why industry, we didn't really talk specifically about any of these industry verticals. It applies to all of them, correct?
Yeah, absolutely. And I think we're in a unique time where this technology has been proven for 40 or 50 years, but it has been only used typically in big CapEx investments, right? Let's test this out or that out. But where technology has come along and with the data that all these organizations have, we can take those that proven technology to simulate and test decisions, integrate it into your real-time data so that we have that simulation-based digital twin, and then answer different types of questions so that doesn't require a big CapEx investment to justify having the model. It could be, well, this person didn't show up today, or we got this priority order. How do we sequence it? We have this disruption. What do we do? And all the questions that we went through today. We're in an interesting place where the challenges that these leaders have across industries are shared because they're all very complex. They're resource constrained. They're trying to get more out of what they already have. And simulation is uniquely positioned to help them solve those.
If I'm somebody who came to this webinar, I'm thinking to myself, well, that's interesting because we talked about these planning tools, software packages that can't do the things that I'm trying to do here. That being said, we've been talking now for 38 odd minutes. You haven't mentioned a single software package. You haven't mentioned a preferred platform that you use for simulation. Maybe just for the audience here, just spend a minute and talk about the fact that your team basically platform agnostic. You've got this whole portfolio of tools, or you'll also use tools that your clients are familiar with. I feel like if we're going to have a show about tools, I should give you a moment to talk about tools, and we haven't done that at all.
Yeah, that's a great question. And part of the reason for that is simulation is the backbone of most of the work that we do. But it's not the only tool, and it's not the only tool that we use to solve these problems. Some of them require simulation and optimization, or simulation and AI, or data science and data engineering. So there's a broader set of technology that we bring to the table to solve these complex problems. But from a tooling standpoint, there's a lot of simulation software packages out there that we work with that, but we're relatively agnostic, as you said. And so we can help you choose which tools are right for you, or make recommendations based on what you're trying to do.
Outstanding. Well, that is wonderful. John, I want to thank you so much for joining us today. This has been a really fun one. As John mentioned, what you saw today was the live version of 8 questions your supply chain planning tools can't answer. We're going to get you a copy of that ebook as well. If you missed it last month, John and the SimWell team were out at Manifest. Those of you in the mining industry, PDAC is coming up in just a couple of weeks.
We'll be around. So we'd love to connect if you're thinking about this and you want to see where it'll fit.
Outstanding, everyone. So obviously you can learn more from John or anyone on the SimWell team at simwell.io. For everyone on the SimWell team, thank you for joining us for today's webinar. SimWell, folks, how decisions get made, simwell.io. Thank you so much.